Hello and welcome to day 9 of our low-level design course. Today we are going to explore two incredibly important concepts, dependency injection and inversion of control. These ideas are everywhere in modern software systems, whether you are building a tiny app or a massive enterprise system. Once you master them, you will write cleaner, testable, and much more flexible code. Let's dive right in. Alright, let's start with dependency injection or simply DI. In simple words, DI means that an object does not create its own dependencies. Instead, it gets them from somewhere else. Think of it like hiring a contractor. You don't manufacture the tools they need, you just give them the tools. This idea leads to cleaner design because classes don't need to worry about how to build their dependencies, just use them. Now, dependency injection is just one form of a bigger idea called inversion of control or IOC. Traditionally, code controls everything. It decides what to instantiate, how to wire things together. But with IOC, we flip that model. We hand over that control often to a framework or an external entity. So the framework decides when and how things are created. Dependency injection is how we implement this inversion by injecting ready-to-use dependencies into our class. You might wonder why bother? Well, when classes directly create their dependencies, they become tightly coupled. That's bad news for testing, flexibility, and long-term maintenance. But with dependency injection, we can swap out implementations easily. For instance, in testing, we can inject a mock instead of a real service. In production, we can inject a different version based on configuration. In short, DI helps us achieve loose coupling, high testability, and future-proof designs. Now, there are three major types of dependency injection we should know. First is constructor injection, where we pass the dependencies at the creating of the object. Second is setter injection, where we set dependencies later via public methods. And third is interface injection, which is less common but still important, where an interface forces an object to provide its own dependencies through specific methods. Each method has its own strengths depending on the situation. Let's look at constructor injection in action. Imagine a car class that needs an engine. Instead of building the engine inside the car class, we pass the engine in when constructing the car. This ensures that the car always has a working engine and we can easily substitute a petrol engine, diesel engine, or even an electric engine depending on the need. Constructor injection is the most preferred method when a dependency is mandatory for the object to function properly. Here's another pattern, setter injection. This time the car has a method like set engine to install an engine after it's constructed. Setter injection gives more flexibility, like configuring optional components later, but it comes with a small risk. The object can exist in a semi-initialized state until all dependencies are set. It's best used for optimal dependencies or where late binding is necessary. Dependency injection isn't just theory, it's everywhere. In the backend framework like Spring Boot, services are automatically injected for us. In front-end frameworks like Angular, components receive their dependencies via injection. In mobile apps like Android development, libraries like Hilt and Dagger manage DI. Even in games, platforms, physics engines, or audio engines are injected depending on the platform. Mastering DI makes us much more comfortable with modern software development. Managing DI manually is fine for small projects, but as projects grow, we need automation. That's where dependency injection containers come into play. These are special libraries or frameworks that automatically resolve dependencies, instantiate objects, and even manage object lifecycles like singleton, scope, or transient. Examples include Spring's IOC container, Juice for Java, Boost.di for C++, and even .NET's Core's built-in DI container. Before we run off and apply DI everywhere, beware of some common pitfalls. First, don't inject too many things into one class. If you have 5 or 6 dependencies, maybe we need to rethink our design. Second, don't make all dependencies optional. That leads to fragile objects. Third, don't over-engineer small projects by building complex DI setups. It's important to match the complexity of the solution to the size of the project. Now it's your turn to apply these ideas. Try implementing a payment service that depends on a payment gateway. Pass the gateway using constructor injection. Then take an old piece of code you have written earlier and refactor it to use DI instead of direct instantiation. As a challenge, you can even build a tiny DI container. Trust me, it's a great exercise to truly understand how dependency resolution works. Alright, to summarize everything we learned today, dependency injection allows our code to be loosely coupled and easily testable. Inversion of control is a larger principle at work, and DI is one of the most effective implementations. Constructor injection is usually the best approach for mandatory dependencies. And remember, good design is about making our code base easier to change, extend, and test. DI is a major tool in that toolbox. Great way reaching this far. We are building solid engineering muscles. Thank you for your attention.